Hey folks, Jonathan here. Lighting's not the best in the world, but I was going to try to show you this mill. I have it sitting in the shop here, trying to do a little cleanup on it. And what we're using is navel jelly, and then I'm using a razor blade to scrape off what the navel jelly has brought up, and then cleaning it up with steel wool, because we don't, of course, don't want to scratch the surface any. But it's coming out pretty good. I think it's going to clean up all right. And couple of good things, well, one good thing, the DRO comes on. Now, I don't mean it works, and I'm going to cut the wires and splice them all together, and there's about, I don't know, 8 wires in each. I don't know why they cut all this stuff, because they even cut the power cord going to it right here, and they cut these wires twice, so everything was cut. I mean, they must have just didn't want anybody to be able to use it or something, I don't know. But that may be okay. We'll test it out some more. We'll get it hooked up to the sensors, or whatever you want to call them, glass scales or scales. But anyway, what I've done is I've got a temporary wire up here, and don't try this at home or at work, or definitely not at work. But anyway, I'm just going to give it a try. And I don't know if anybody's ever used the navel jelly before, but you can see it. It actually eats the rust up, and then I can basically take the razor blade and pretty much just scrape it off without hurting the surface any. And then I go back after I get it good and clean. Just keep adding some after you clean it off, and eventually you'll get it down where you want it, and you can take the steel wool and clean it up. And like I said, I don't know how well you can see this. It's still as smooth as can be, but there's still a little bit of dark spots from the rust. But we'll get it all cleaned up. I got the vise off, and of course these are stuck in there, pretty rough. But anyway, I have not tried it yet. I just got finished wiring it, and we're just gonna turn the phase converter on. And this wire I've got running over here is actually a wire that I sort of keep hooked up. I keep the caps on it, but or the wire nuts on the ends, and then I got a main switch for that wire that I keep cut off, and it's sort of a test wire. And then if I'm running a machine outside, I want to hook something up, I can hook it up. But anyway, let me get you on the stand and we'll check it out. Okay, we've got it all on and everything, and we'll give it a try here and see if it'll work. Those sparks or something. That wasn't good. I guess that was water. When I turned it on, I guess there was water up here in these belts. And slung it all over my face. So, anyway. Let's see. Well, I got it hooked up backwards, but you can swap any 2 wires. Let's try it back the other way. Yeah. Seems to work good. Sounds good, nice and quiet. I don't hear any bearing issues. See if I can figure out the power feed on this. I'll figure it out, I guess. A little different than my Bridgeport, but it's working. It'll work better. We get it cleaned up, get some oil on it. Working good. Well, I thought I had it hooked up backwards. Let me see. I guess I don't. But high gear. like the other one. Works really good. I'm surprised. Alright, I'm going to keep on the table and I'll update you as I go. Okay folks, we're getting there. One problem. The table rolls in fine. When you go to back it out, because it's pulling this against here, hopefully you can see that, this shaft is bent where they hit it and bent the handle. So it's not wanting to come back right. It's actually binding. So what we're going to do is find out where it's bent, and then we're going to take one of our lead hammers and we're going to try to straighten it out a little bit. I mean, probably not the right way to do it, but we're going to do it anyway. Of course, it's bent right on that. Well, it's already working a lot better. I think we'll get the... Alright. That'll work. I know you can't see it, but I'm just trying to get the highest side, which is right here. We'll move our indicator. Oh, way too far. Learned a good lesson there, didn't we? Don't hit it too damn hard. Them hammers are heavy enough that they really move it. If I go to moving too much, we're going to end up breaking something. I didn't think it was going to move like that, or I wouldn't have hit it so hard. Alright. Right here is our high spot. Of course, this is all sliding off too, but alright, we're about 25 thousandths off. Okay folks, I tried to do a video on fixing this handle here and getting it straight, but I guess my battery went dead while I was doing it. So anyway, I've got it done. It's not exactly perfect, but I mean it's so close that not a problem. So it works good. The other handle, the big handle for the to raise the knee up and down, he had given me it, and he actually gave me two. He gave me one that wouldn't fit it, but it did fit my Bridgeport, and it's a whole lot nicer than the one I had on my Bridgeport. The one on the Bridgeport, the knob didn't turn. It was a solid mount. So, and I had two of them, but they both were the same way. But the one that he gave me turned, so it's in a lot better handle. Now I know we got some major issues on the other end of the machine that I'm not going to tackle quite yet, but what I am going to tackle is right here. This one's been also. So if you watch the space between the dial and the table itself, you can see how bad it is. And this handle's bent this way. So I think, well, it's threaded in, but I don't know how they got it in there. Unless there's an Allen head in the back of it or something. We'll check that out. But hopefully we can get this straightened out and get this straightened out. Now what I'm doing is putting a dial indicator on it, turning it, and then I'm actually using a lead hammer and hitting it to knock it where it needs to be, because you know, that's just the way we're going to do it. I'm not going in to turn it all apart just to try to straighten the shaft out. That sure is better. About got the handle right, but I can't figure out how to grab that bolt. There's no set screw in it or nothing on the inside, or it's not an Allen screw. I figured that's what it would be, but it don't feel bad. It's a lot easier than it was. And it's not perfect, but it's going to do. Alright, I think next what we're going to do is I'm going to try to wire up the DRO, and I'm going to have a lot of wires to splice together here, but we're going to try it and maybe we can get it to work, and we'll just keep moving on. Table's not quite done. It looks a lot better than it looked. You know, got the heavy rust and stuff off of it, but it just needs probably Scotch-Brite and go over it really good. But I oiled it up so it wouldn't rust anymore. And, that navel jelly is sort of a gel acid, so you know, I wanted to do everything I could to stop that from, you know, working anymore. And you know, just cleaned it up really well, and then oiled it up. So anyway, we'll keep at it here and see if I can get this DRO working. Okay, and just so you can see what we're dealing with here, we've got 9 wires and then the outer ground. And these are little tiny, like phone line wires that aren't really good to be splicing together, but you know, you can about strip them by hand. But we're going to put them together either way. But I'm not going to run them long through the wire because they cut it twice. I'm just going to run them short right up to the DRO. And let me see. Well, actually, right here's the wires, so we can run it right up to it just temporarily, and we'll see if it works. And don't matter which one I hook to which. You know, even if you're backwards, I think they'd be okay. You know, just to test. So the plugs should be the same on the back, so we could actually switch the plugs. We've got it on here, and we're working. So far so good. This is going to be the major problem. You know, this piece here I believe is separate from the drive. Now this arm's bent too. I mean, it does work. Well, I say it's bent. It's pretty straight. So maybe they missed the handle and just hit this. Anyway, we can pull this off and see what we can do with it. Okay, here's what we've got. You can see where it's broke across there. And it just broke where the bolts go in. It's missing some piece there. And so we're going to have to replace this. And then here, our feed, when it knocked down, it actually pulled this bearing out. This bearing's about not quite a 1/4 inch out from where it seats in at. I really think I can get by with this. I don't think I'm going to have to do anything about it. Once it's mounted back on good and straight and solid, this bearing's knocked back, or this race is actually knocked back in where it needs to be. Worst comes to worst, I could fill it in with a little bit of JB weld. I don't think it's going to be an issue though once this is mounted good and solid and straight, because all it's got to do is be straight and hold the bearing straight, and I can get that bearing back in, or the race back in where it needs to be. So I don't really see that as being a problem. Let's see. Yeah, see, it's not even going in far enough to hit the gear, so I know that the bearing's got to go back farther, and you can see where it was rubbing on here. So I think we'll be all right on this piece. I don't think we may come up with something to cover it. I'll figure that out as we go, whether I'm going to machine anything or do anything. But this piece here, I don't think I'm even going to look to see if I can buy this piece. I think what I'm going to do, I'll take this off, and I'm not going to say this is the right way to do this. You know, there's other ways of doing this. I'm not going to make this piece out of wood and then try to cast it. I think it would be more trouble than what I want to do. What I want to do is take this off, hold it back together somehow, use some Bondo, fill it in a few places, you know, maybe partially fill in here. We're going to have just a little bit of shrinkage, but the shrinkage we have, you know, we can actually build up on the sides if we need to with Bondo or whatever we need to do. But what we're going to do is we're going to make this into a foundry pattern instead of trying to make something out of wood, because you know, making it out of wood to me is, you know, time consuming. I'm not a woodworker, so, as everybody knows. And but I think I can use this because I think the whole back side of this thing is flat. It may be machined a little bit, but I mean, it's basically a flat piece. I'm going to go ahead and try to get it off, but I think we can work with it. I mean, that's really our only issue. You know, there's actually other ways that it could fix it too. I mean, if I didn't want to do that, I could go in here and machine this all down. Well, you know, I could probably get an 1/8 inch and then build a steel 1/8 inch round plate that would go in there, and you know, that would screw on everywhere and hold it back together where it needed to be. And there's plenty of ways of doing it, but this, to me, this is a little bit more critical than what this is, because this is not a bad issue here. I'm not really worried about that too much. But I think we can get it back together doing this, and then maybe we'll do a little bit of repair on the power feed. But you know, the shaft I checked, it's not bent at all. It didn't bend it any, and you know, when it evidently hit it low, and it just broke that, and then was actually forcing out on the bearing, so it had forced it out a little ways. But that's actually the inner race for that roller bearing or needle bearing, and the needle bearing just slides in there. That's the outer race for it. So yeah, it's loose in there. We'll have to knock it back in where it needs to be, but I really think I can do something with it. And you know, that way we'll do this without spending any money. And it's not, the money's not the issue. You know, I'm just trying to show that if somebody don't have any money, that don't mean they can't, you know, do something they want to do. And there's the readout, works good. On that side, I'm going to wire this other side up, and I'll show you whether it works or not here, and we'll go from there. Okay, folks, another thing I was just thinking, I may want to test this. Now, I did test the gearbox in it, so it's fine. Seems to be really good. Just turning the gear and putting it in gear forward and reverse. But I don't know how much voltage this is supposed to be. I'm assuming, you know, I know this is the power wire, and I know this is actually the wire that goes to this limiter switch, or whatever you want to call it, which is this switch here, and it's stuck. That side ain't stuck. This side's stuck. But basically, it comes up and hits, and that's what, you know, stops your travel. And they just cut the wire on it, of course. Somebody was definitely wire cutting happy, I swear. But I don't know how much voltage this is. I'm assuming that it looks like it's just a 110 setup. But I'm gonna maybe do a little checking online and see if I can find out before I just jump in there. Okay, folks, we've got this off, and I kind of laughed. I tell you what, it's so daggone cheap made that I know it's die cast, but I mean, that's almost pathetic that it's You know, they've done everything they could do to lose weight on the daggone thing, and it's just, I don't know. Kind of bothers me to see stuff like that, but you know, I'd have built it solid. I'm going to build it solid. It'll be one piece, and you know, I could actually, if I had just a half-inch block of aluminum, or a piece of aluminum, I could build that without this lip on it. You know, that dust shield or whatever. But you know, we want to have it on it, so I think that's what we'll do. Is we'll glue this thing back together somewhere, somehow, and start doing some bondoing. And we'll fill all that with bondo and just make it smooth. And shouldn't be too bad. I think we can make that. Okay, our DRO is not working. It's trying to, but it's not working on our X. And I think the reason why, I got looking up under, I'm sure I didn't notice that wire's just smashed. So hopefully, I don't know what it's going to take, but there's enough wire there. If I have to, I can solder it and splice it, but it's going to be a pain in the butt either way. But we'll see what we can do with that. And for now, let me see. I think I'm going to work on trying to get some wires on this and just see if it'll run. Right. Well, folks, I think we'll go ahead and end this video here. I haven't hooked it up to anything, I'm afraid. I did some checking online, and these things could have came 12 volt or 110, and I just don't know what it is. The color of the wires kind of make me think it might be DC. I pulled the wires back. We got a black and a green and a red, but you'd think black and red would be positive and negative, and then on a DC system, and then a ground maybe. I don't know. You wouldn't think it'd have a ground either, but it's, if anybody knows or has any info on them, this particular one, I mean, the tag that's supposed to be on it I think is missing, but this is an HCW 135, and like I said, it could have came either way, and I can't find anything, you know, to tell me what it is for sure. But anyway, all right, we're going to keep on. We've got other stuff going on too, but we're going to keep on cleaning on this thing, and we're going to go ahead and make a piece for that. We'll machine it, and I'll show you doing that. We still got all the T-slots and inside the little holes there to get, and it's looking better. I think I'll try to run a new wire up from this scale, glass scale, whatever you want to call it, and maybe we can get that DRO working on this side too. But anyway, appreciate everybody watching, and till next time, bye.